So let's look at an example that talks about the population proportion where we're trying to find confidence interval. Let's consider that we have a random sample of 100 fish hatchlings from some pond, let's say on a fish farm, where 25 in this sample are found to have 3 eyes. So the question is, we want to find a 95% confidence interval for the proportion of freaky fish hatchlings in the entire population. So what we want to do is use a sample of 100 where 25 are freaky to find a 95% confidence interval for the population proportion of freaky fish. So how do we do that? Here's the solution. We've been given n equals 100. P hat can be found by taking the 25 freaky fish divided by the sample size, which will be 0.25, and we've been told the level of confidence is 95%. So using a 95% confidence level, we've seen in previous lectures that when we use the Z table, and we're using Z in this question because we're talking about a proportion type problem, if we look up 0.475 on this side of that vertical line, we go into the Z table and then out to the edges in that Z table, and when we find this area 0.475, we find the critical value of Z will be 1.96, and we've done that several times in earlier lectures. So now we can actually find the confidence interval estimation of P by using this formula here. So at this point we now know what P hat is because we found that here. We can substitute in the critical value of Z, which we've just found. And this particular part of the formula, well, we know P hat, so we can put that in here, 0.25, and we can put in 1 minus 0.25. And you'll see that just before there, I put in P hat here and the Z critical. And we also know what little n is, that's the sample size, and we can get that from up here. So we put little n equals 100 in here. Just be careful to put 100 there as the sample size and not the 25. The sample size is n, and that is 100. So once we've got these numbers in here, we can actually work out the bit under the square root sign, and that turns out to be 0.0433, and that thing under the square root is what we call the standard error of the proportion. So once we now multiply this standard error by the critical value, we get 0.08487, just slide it up there, and that's called the sampling error, and we've been denoting that as big E earlier on. So we're almost there because all we now need to do is say that the upper interval limit is the 0.25 plus the sampling error, which is here. So if we add those two numbers together, we get 0.335. And to get the lower interval limit, it's 0.25 minus the sampling error, and that's 0.165. So there we have it. The upper limit for the population proportion is 0.335 over here, and the lower limit is 0.165. Now that's noticed to 3 decimal places. Now if we want to change that to a percentage, it's a simple matter of multiplying this number by 100 and this number by 100, and here we have a confidence interval for the population proportion as a percentage. But how do you actually interpret this particular confidence interval? What does it actually mean? Well, the best way to do that is summarised here. To interpret the confidence interval we just found, what we can say is that based on the sample, which was 100, the proportion of freaky fish hatchlings in the entire population is estimated, that's the key word, it's just an estimate, and we use 95% confidence level, so it's with 95% confidence, to be between 16.5% and 33.5%. So in other words, just based on one sample, we've been able to make an estimate with 95% confidence that the true proportion of freaky fish in this population is somewhere between 16.5% and 33.5% as being freaky. So in other words, that's the 95% confidence interval for the proportion of freaky fish.